Hello and welcome to another Algebra 1 video. We are doing 9.1 today, which is graphing quadratics. So this is a Desmos heavy lesson. So I'm going to be doing a lot of Desmos here. What we're doing is finding solutions of quadratics. What solutions look like, and I'm just going to sketch on the graph, is solutions are x-intercepts. So solutions of quadratics are x-intercepts. So when you're looking for solutions for a quadratic, there's actually three different options for how this can look. The first option is you have a quadratic up here or down here. If it never goes through the x-axis, this is the zero solutions option. This has no solutions. All right, let's go to the second version. Erase these graphs. And what if it looks like this? Like an up parabola that bounces off the axis, or a down parabola that bounces off the axis? This, oh, that's a beautiful parabola. That's supposed to be a U. It's a little malformed. Anyways, doink and doink. They touch once. These are one solution because there is one x-intercept. X-intercept being where we go through this flat line at 0 here. And so each of these would have one solution. And the solution would just be like x equals, in this case, 2.8 or something. Just guessing based on that. And this one here, like negative 1.8 or something like that. I'm just guessing where the quadratic hits the axis. It's going to be a lot more obvious in a lot of our examples where it hits. And our last sort of example is the two solutions versions. So quadratics are weird. Unlike lines, which always have one solution, quadratics can have 0, 1, or 2 answers. And it depends on how the graph looks. So our last case looks like this. Or like this. If it goes through the x-axis twice, once here, or once here, then those values are my solution. So it'd be like x equals 4.2 or something like that. And x equals 0.8. And those would be the solutions to this. So solutions are just x-intercepts, and we read them from a graph in Desmos. So let's go through a couple examples, like actually in Desmos. How would you do this? Well, the first way I'd do this is, say I'm given a question like, I'm going to write it in my scratch pad here. X squared minus 3x plus 9 equals 0. If they say, find the solutions to this quadratic equality here, what I do here is just dump this into Desmos. X squared minus 3x plus 9. X squared, minus 3x plus 9. And you may notice this parabola, its lowest point is at 6.75. There's no x-intercepts. So this would be no solution. No solution. So 0 answers. Okay, that's one down. Let's, there might be a question you have. If you look at my scratch pad, I wrote x squared minus 3x plus 9 equals 0. Now, I did not write the equals 0 when I graphed this. What if I did write the equals 0? Wait, where did it go? It doesn't exist. That's because what this graphs, if you put the equals 0, is where it equals 0, and it never equals 0. So it graphed nothing. So this isn't particularly helpful. That's why I recommend just doing the left side or the right side of the equation in this case, the side with the x squared, or writing y equals x squared minus 3x plus 9, because this will always give you a parabola, and it'll be more obvious whether or not there are 0, 1, 2, or 3 answers. Now, let's change our equation. What if I put x squared minus 6x plus 9 instead of minus 3x? Well, you may notice now I have an x-intercept. Boom, 3, 0. And in Desmos, it's really easy. You just click on the dot at the bottom, and it tells you the answer. So, boom, one answer, x equals 3. One answer, x equals 3. Cool, done. Now, what happens if I put 0 equals x squared minus 6x plus 9? You may notice I actually have something on my graph now. It actually pops something on here. So if my equation was 0 equals x squared minus 6x plus 9, it gives me a straight up and down line at x equals 3. And x equals 3 is the answer, so it actually gives you the answer whether or not you type in y equals or 0 equals. It just gives you a prettier picture if you put in y equals. It actually gives you a parabola. All right, now let's do our last case. Our last case is 2 answers. So I just changed this to a 9. If I look at this now, I do have 2 answers. I have one here and one here. And so I'd have 2 answers. X equals, what is this point? It's some janky garbage. 1.146. And 7.854. So I'd say x equals 7.854. Again, if you would put a 0 here instead of the y, you get 2 straight up and down lines at the 2 answers. So it doesn't matter if you put y equals or 0 equals, you get the answers when you plug it in. The only case that's convoluted is our first case, where this was a 3, because it gives you nothing. And that's a little confusing to look at. So I do recommend the y equals way when you graph these, and then just click on the x-intercepts instead of getting them straight up and down lines, because it just is easier to tell what's going on for me in this case. So now let's look at another type of example. What if they ask you, this one's what I want. What if they ask you something like, 1 equals 2x squared plus 3x. Solve this. Few different techniques here. First technique, get it equal to 0. 0 equals, wait, I subtract 1 from both sides. So 2x squared plus 3x minus 1 equals 0. And then I just go graph this. So 2x squared plus 3x minus 1. So get rid of this. 2x squared plus 3x minus 1. Oh, I get to keep my 2 answers thing, but the 2 answers are going to be a little different. First answer, negative 1.781. Negative 1.781. And my other answer here at 0.281. Boom. That's one way of doing it. So I just rewrite it so it equals 0. And maybe you're unhappy. Maybe you want this to be 0. Boom, we get the 2 answers here, 2. Right there, 0.281. And boom, right here, negative 1.781. All right, there is another way to do this. If I look back at my equation, what I can do, instead of subtracting 1 from both sides, is just graph each side of this equation in Desmos. So graph 1 and graph 2x squared plus 3x. So the way I do that is I go over here, and I'm going to get the same answer, but I'd say y equals 2x squared plus 3x, and y equals 1. And then I just look where they intersect, where these two lines intersect. And 0.281, negative 1.781, got the same answers this way too. So if you just do y equals each of the sides and look at where they intersect, that also works for solving questions like this. The only thing that makes this different than the 0 sign is 0 is just the x-axis, and so we don't actually have to do a second equation when we subtract 1 from both sides. And so it is maybe a little easier if you do this the subtract 1 from both sides way. So doing this is probably the easier technique. All right, hopefully this makes sense so far. We are just graphing in Desmos, looking for x-intercepts. And sometimes there are 2 answers, sometimes there's 1 answer, sometimes there's 0 answers, depending on the characteristics of the graph. Now, the last part is one question on this homework. We'll ask you to do it with a table. So figure out how many answers there are with a table. So if we have something like, let's do x squared minus 4x minus 5 equals 0. If you want to figure out where this equals 0 from a table, tables look like this, x, y, and we just test values. Now there's a really smart way to do this. Since you're doing this at home and you have Desmos, if you have to build a table for this, you could try 0 first, because 0 is not a bad value to pick. And if you choose 0, you get -5. Crud, that's not one of our answers. Feels bad. Let's try using 1. 1 minus 4 minus 5. That's -8. That's not the right answer. That's not a 0. What I want is y to be equal to 0, and so I haven't found it yet. So if you want a hint on how to find the right points to plug into your table, here's how. We just go to Desmos and go x squared minus 4x minus 5. And those 2 x-intercepts, those are what I want to try in my table. -1 and 5. So if I warp back to my table, let's try -1. And if I do that, I get -1 squared minus 4 times -1 minus 5, which is 1 plus 4 minus 5, which is 0. Hey, what if I try 5? If I do that, I get 5 squared minus 20 minus 5. That's 25 minus 25. Hey, I used a table to figure out that there are 2 spots where it equals 0. X equals -1 as an answer, and x equals 5 as an answer. So don't be afraid if you get a table. You can use a graph to help inform you of this. Now, there is another kind of problem that I didn't warn you about. There is a kind where they give you a graph, like say they give you a graph like this. And then they give you a bunch of equations. Y equals -x squared plus 3x minus 4. Y equals -x squared minus 3x plus 4. Y equals x squared minus 3x plus 4. And y equals x squared plus 3x minus 4. So these are all just like a bunch of equations that are very similar but have the negatives swapped or whatever. So let's say these are your A, B, C, and D. Option 1 for solving a question like this is to plug each of these into Desmos and see which one has exactly the same graph as the one that you see in your homework. That way is totally legit. But that takes a tiny bit of time. There is actually a shortcut. If we look at this graph I drew here, it has a positive y-intercept, and it's an up parabola. So because it's an up parabola, I know it has a positive x squared first. If it had a negative x squared first, like these first two, a and b here, it would be a down parabola. It's an up parabola, not a down parabola, so I can instantly get rid of a and b. Now, my y-intercept is positive here, which means, if you remember from our standard form talk, that last number in standard form is always our y-intercept, and I want a positive y-intercept, so I know it's got to be this guy. And so that's a way you can figure these out without actually having to go to Desmos and graph each one of these. Just kind of analytically eliminate things until you know that the last answer is your right answer. So just a trick to figuring these out in the case that you see these on your homework. All right, last piece I need to talk about is the Ospi updates. So OSPI is like the head of schools in Washington. And they put out an update saying that we are not allowed to give pass-fail, so pass-fail is eliminated. Most districts were looking at something like a pass-fail, and so OSPI put their foot down and said that's not happening. So the governor and that sort of thing. So we are giving grades. The way Issaquah school districts decided to do it is your midterm 3 grade. In other words, your grade based on stuff that we did before we left is your grade is the lowest your grade can go. It can get better based on the work you do during quarantine here, but it can't get worse. So if you have a B in the class, you are not going to get a C for this semester. It is illegal for me to give you a C. If you have an A based on stuff you did before quarantine, you can't get below an A. If you just do things, you will end up in an A. Now, if you do nothing during quarantine, we are allowed to give you an incomplete. So the people who do nothing are going to have I's on their transcript. Now, if you're watching this video, this isn't really a risk for you because you're probably doing things if you're watching this video. But an incomplete is for like not if you do like even less than half of the stuff I assign or something. I'm probably going to give you an I, especially if your grade was an F or a D coming into this. And so I'm going to be giving out a fair number of these, probably. To not end up on this list, just do things. Like, there's no assessment you can fail to end up with an I or anything like that. It's if you do all your homework and are, like, attentive and maybe show up to live streams or that sort of thing when I start doing those for Algebra 1, again, you're fine on that front. Your grade will get better. So for many of you, getting better is the more likely results. You cannot get worse grade-wise, but you can end up with an incomplete. The way you make up an incomplete is you either work with me to get that incomplete fixed, or the district put out a couple other ways. I don't really know those because they don't really pertain to me. But try to avoid getting an I. I's are lame. So just do things if you can during this stretch. And I'm can assign at most 1.5 hours of work a week. That includes watching this video. So the homeworks are designed to take like 20 to 30 minutes, and the videos are 15 to 20 minutes. And so that's how we're doing that combo twice a week, about 45 minutes twice a week. So that's some kind of brass tacks about what we're doing and the legality of everything and all that sort of stuff. So don't worry about your grade if you're happy with it, and if you're not happy with it, do stuff and get a better grade. That's kind of the moral of the story. If you end up with an incomplete, come talk to me next year, assuming we have school in September of next year, which is maybe, probably maybe, I don't know. I can't really anticipate. All right, last piece is I talked about live streams. I was doing these before this, but the new schedule had kind of cut me back a little bit. So the other class I teach is AP Calc, and AP Calculus has an AP test on May 11th. May 13th is the Wednesday after that. I always do these on Wednesdays, so I do them Wednesdays 2 to 3. That's the math window. I'm going to be doing these for Algebra 1 starting May 13th, because that's the Wednesday after we have the AP tests. So starting May 13th, Wednesday, from 2 to 3 p.m., I'm going to start having Algebra 1 live streams again where I do homework help or grade questions or any sort of things like that. We do practice. Maybe go over a little more in detail, try to answer people's questions, that sort of thing. So those will be starting again, and we're talking 2.5 weeks. And I'll be using the Wednesday 2 to 3 p.m., assuming there's attendance for it, like people are showing up and getting value from it, until the end of the year. So it's a little limiting the amount of space I'm allowed to use. Otherwise, I'd be running live streams for Algebra 1 right now, but I definitely need them for calculus for the next 2 weeks, and then I will be switching to Algebra 1 for the rest of the year. So I will be streaming these on YouTube. If you've attended them so far, you probably know what's up, but otherwise, at 2 p.m. on Liberty Math and Stuff, my YouTube channel, what all of my videos on my website link to. Or the link that I put on my homework calendar, which I will for the live stream or my YouTube channel. You just show up and you can ask me questions and chat. It's just on YouTube Live. And I can try to help you with math questions. So far, they have been fairly well received from the people who have showed up to them. People get in some good practice and are able to collaborate with each other and that sort of thing. So they're pretty good experiences. And again, those are starting May 13th and going through the end of the year. Anyways, that's enough logistics stuff. Hopefully, this is helpful for you if you had any questions about any of this. And good luck on that homework. Later, dudes. And dudettes, I guess. Bye bye.